All right. How do I test anomaly detection models? In this video, I'm gonna explain the way I evaluate or test my anomaly detection models. And I will use store sales anomaly example that I already explained. And you can go back to this link here for more details, but you should be able to follow this video's topic independently. So I will first look at the data, import it and visualize it, and then I will find anomalies. Third step is going to be creating synthetic anomalies. And then we are going to predict the anomalies in this synthetically created anomalies data with the model that we already trained on, model step 2. So the final step is going to be looking at these predictions and see how is the accuracy, if we like it or not. Okay, let's import some libraries and then import the data which I have it locally, and you'll see it in the Git repo that I'm going to attach to the description. It has invoice date and weekly sales number. If you plot this data frame, you're going to see some of these sales numbers are anomaly, either too much or too low sales for that week. And we can find this with isolation forest that we already talked about that. But briefly, we instantiate the isolation forest instance with 150 estimators and contamination of 10%. These are numbers that can be changed for your application. And then we can fit predict this instance anomaly detector that we already instantiated with the data that you already have, the whole data for this example. And this is going to predict, because it is first fits and then predicts the anomaly points. So we're going to store those anomaly points in this column called anomalies. And we're going to append it to the last column of DF weekly data frame. If we do that, and if we plot two graphs, which first one is the original graph, blue lines, and the second graph is the anomaly sales graph. And we have filtered it for anomaly points, which are -1 in the isolation forest, -1 for anomalies, and 1 for not anomaly numbers. You're going to have this nice graph with red dots, which are anomalies from isolation forest perspective, and the rest normal points. Now, in the next step, we want to evaluate how this model is working or is going to work in the future for the new coming data. For that, what we can do is we can create synthetic anomalies, either synthetic or real, depending on your situation. If it is manageable data set and you like to have more realistic test data set, it's better to have it manually manipulated based on what you think is normal and abnormal. But in this example, I'm going to add a constant number, like 50% of every third row. So every third row, I'm adding 50% of that number to the original number, and I'm storing it, I'm replacing it with the previous number. And I also need to mark this as anomaly that I have created in the same indexes, every third row. And if you do that, you're going to see like these every other third is anomaly points, and you can have the previous anomaly points, and that's totally fine. So next step is to see how much of these anomalies that we have created we can detect with the previously trained model. Remember, we trained, fit, and predicted this model, which is called anomaly detector. We're going to use this model to predict this newly manipulated data frame and see how much of these we can discover or detect as anomalies. So if we do that, this time we're going to use the same previously trained model with just predict, because we want to just predict. Predict with this new manipulated sales values. So remember, these numbers are manipulated every third row. If you even look at these numbers, 3945, and that was originally 2630. So it's increased 50%. Now we want to predict to see which ones we can detect successfully. And we're going to add it to another column just to make it clear. And if you look at the head, you're going to see some of these are easily detectable by the algorithm, but some is still previous model thinks that it is not an anomaly. So our goal is to see how many we missed and how many we detected correctly. So we can have a good comparison between these points and these points, these predictions. So these are, in fact, a ground truth that we have created for ourselves. And we know these should be almost correct because we intentionally create those anomaly points. And these are the predictions of the models, so we can compare these two. And for that, I've used F1 score. You can use other matrix. With this, if you print, F1 score is 83%. Obviously, you can reject this model or accept it based on how sensitive the application is, or you can dig into more details like what precision you like, what recall you want, and what are the false positives that you can accept, or what are the false negative that you can accept, which ones are more important for you. Then you can go back and change some probably things in the model and train it with other models or other hyperparameters. But the whole goal here is to look at this measure at the end and go back and reflect on what you've done, all those steps in preparing data and training your model to get a good model which is acceptable for everybody. All right, we covered a lot in a few minutes, so please download the code and try to change it to other anomaly detection examples, and let me know if you have any questions. Don't forget to like or subscribe, and see you in next video. Thank you.